Now that we've spent some time working with rational expressions, how to simplify them, how to multiply them, how to divide, now we're going to take them to an equation. How do I solve an equation that involves some fractions? So for the first part of this lesson, we're going to focus on fractions that are one fraction on either side. So it's going to look like a proportion. Remember, to solve a proportion, we're going to find the cross products and set them equal to each other. Basically, we're multiplying the diagonals. 3 times x is 3x. 1 times 5 is 5. And then we solve it and get our solution. X is equal to 3/5. Here, 5 times y is 5y. 3 times 2 is 6. Solve the equation, we get y is equal to 6/5. Same thing here, we got 1. I got formatted wrong, so it got pushed to the next line. 3 times 27 is 81. 6 times x is 6x. We divide by 6. And x is equal to 81/6. Or we can simplify that to be 27 halves, which is 13 1/2, or 13.5. So we're going to use that idea of solving proportions to help us solve these rational equations. So here are kind of our main steps. If a numerator or denominator is a binomial, so like x plus 3 or y minus 4, we're going to put it in parentheses because we want to know that it kind of travels together as one solid unit. Then we're simply going to write our cross products. Okay, this is showing you what you have to multiply. Then we're going to go ahead and multiply, but that may require using the distributive property, that may require foiling. Remember our first outside, inside, last, think double distributive. Okay? Then we're going to simply solve it using our inverse operations. So that may mean setting it equal to 0 if it's a quadratic function with a squared term. We may need to do some factoring, or we may need to use the quadratic formula. Okay? But then we're always going to check our solutions to make sure we don't have any extraneous solutions. Make sure we know what does and does not work within that equation. So we're going to start with this one. The first thing we're going to do is we're going to find our excluded values. Let's find what numbers we know are not going to work. Well, that just means looking at each of our denominators and telling me what can x not be equal to, because it would give me 0 as a denominator. So x cannot be equal to -3, and x cannot be equal to 0. So now we know to avoid those two numbers should they come up. Then we go ahead and do our cross products. 5 times x is 5x. 4 times x plus 3. So 5x is equal to 4x plus 12. We subtract our 4x to the other side, and we get x is equal to 12. To do our check, we simply go back to the original problem and plug in 12 for x. So I have 5 over 12 plus 3 is equal to 4 over 5. So I'm just plugging in, oh, sorry, not 4 over 5, 4 over 12. 5 over 12 plus 3 is 15. 4 over 12. Those can both be simplified. Here I could divide them both by 5 and get 1/3. Here I could divide them both by 4 and get 1/3. So I did get it to work out correctly. So let's go through a couple more. So same thing, start with your excluded values. Well, x cannot be equal to 0 in the first fraction. X is not equal to -8 in my second fraction. Then I find my cross products. 4 times x plus 8, and then 1 times x squared. So 4x plus 32 is equal to x squared. So this is a squared function, so a quadratic function. So I'm going to need to set it equal to 0 and use my factoring. So I'm going to subtract the 4x and the 32 over to the other side. So we get 0 is equal to x squared minus 4x minus 32. Since it's a minus, I know I'm going to have different signs. So 1 plus and 1 minus. So I need something that multiplies to give me 32, but subtracts to give me -4. Well, that's a -8 and a +4. When I set those equal to 0, x is equal to -4, and x is equal to +8. To do my check, I'm going to plug it in. So I'm going to plug in -4 first. So -4 squared is equal to 1 over -4 plus 8. So 4 over 16 and 1 over 4. Well, 4/16 is 1/4, so I'm good. Now I do the same thing with my 8. 4 over 8 squared, is that equal to 1 over 8 plus 8? Well, 4 over 64 and 1 over 16. If I were to simplify this one and divide by 4, I would get 1 over 16 is equal to 1 over 16. So they both worked. So in this case, all of my solutions have worked. I've not had an extraneous solution so far. All right, so now the problems start to get a little bit more complicated, a little bit more math involved. Again, find your excluded values. What's going to make my denominators into a 0? Well, an h of 1 would make the first fraction into a 0. An h of -2 would make the second one. So those are my excluded values. Now I'm going to multiply my diagonals, my cross products. So 2h times h plus 2. And then here I've got 2h plus 1 times h minus 1. Notice when I'm multiplying, I'm taking that whole term in parentheses, not just times the h and then, or times the 1, but the whole quantity. Now I simplify each of those sides. 2h times h plus 2 is 2h squared plus 4h. Here I'm going to get 2h squared. I'm going to get a plus 1h, but a minus 2h. So that's minus 1h minus 1. Again, I've got squared terms, so I need to consolidate everything together. So I'm going to subtract 2h squared from both sides. I'm going to add the h to both sides. My squared terms are going to drop out, so I get 5h is equal to -1. And I get h is equal to -1/5. So for your check, you can either check this using -1/5 as a fraction, or if you want to change it in -0.2, that's perfectly fine as well. Just make sure you take the negative with it. But I'm going to go back and plug it into my original problem. So I'm going to do 2 times -1/5 over -1/5 minus 1. And I want that to be the same as 2 times -1/5 plus 1 over -1/5 plus 2. 2 times -1/5 is -2/5. -1/5 minus 1, remember minus 1 is really -5/5, so that's -6/5. 2 times -1/5 is -2/5, plus a positive 5/5 gives me 3/5. 2 is really 10/5, plus -1/5 is 9/5. And I want to know, are those equal to each other? Well, they all have the same denominator, so the denominator really just disappears. We can multiply everything times 5 and get rid of that denominator. So I have -2 over -6. Well, that's 1/3. 3 over 9, that's 1/3. So it does work. All right, so that's the end of our lesson. Later this week, we'll work up to some more complicated ones with day 2, but that's the end of day 1.